In the digital age, where information is power and security is paramount, a revolutionary technology has emerged to redefine how we perceive and manage data: blockchain. It's a groundbreaking innovation that's much more than just the backbone of cryptocurrencies. In this video, we'll demystify this complex technology, breaking it down into simple, digestible terms. Whether you're a tech enthusiast, a curious beginner, or a forward-thinking entrepreneur, this video will provide you with a clear understanding of blockchain technology, its purpose, capabilities, workings, types, and its promising future. Let's start. What is a blockchain in simple terms? Imagine you're playing a game of whispers, where a message is passed from one person to another, and by the end of the line, the original message is often distorted. Now imagine if there was a way to ensure that the message remained the same, no matter how many people it passed through. That's the essence of blockchain, in the simplest of terms. A blockchain is like a digital diary that's shared among a group of people. Everyone in the group can write entries in this diary, but once an entry is made, it can't be changed or erased. It's there for everyone to see, forever. This diary isn't stored in one place, like a library or a single computer. Instead, it's distributed across many computers all over the world, making it decentralized. Let's take an example. Suppose you and your friends decide to start a book club. To keep track of who has which book, you create a shared document. Every time a book changes hands, the person who gives the book and the person who receives it both write an entry. This way, everyone in the club can see who has which book at any given time. If someone tries to claim they returned a book when they didn't, everyone else can check the document and see the truth. That's a basic example of how a blockchain works. In the world of technology, this book club could be anything from a group of people making financial transactions, like Bitcoin, to a network of computers sharing data. The books could be anything of value, like money, property, contracts, or even votes in an election. So in simple terms, a blockchain is a transparent, unchangeable, decentralized digital diary that records transactions across many computers. It's a way to ensure trust, accountability, and security in a world where these qualities are more important than ever. What is the main purpose of a blockchain? The main purpose of a blockchain is to enable secure, transparent, and tamper-proof transactions in a decentralized manner. It's about creating trust in a trustless environment. Let's break this down a bit. Security. In a blockchain, each transaction is encrypted and linked to the previous one. This chain of transactions is visible to everyone within the network, but altering any transaction requires changing all subsequent transactions, which is computationally impractical. This makes the blockchain secure against fraud and tampering. Transparency. Every transaction on the blockchain is visible to all participants in the network. This transparency ensures accountability and makes it nearly impossible for any participant to cheat the system. Decentralization. Unlike traditional databases that are controlled by a single entity, like a bank or a government, a blockchain is distributed across multiple nodes or computers. This decentralization means that no single entity has complete control over the entire chain, making it resistant to censorship and single points of failure. In essence, the main purpose of a blockchain is to provide a secure and transparent way for parties who may not necessarily trust each other to agree on the state of a database without needing a trusted intermediary. Whether it's transferring cryptocurrencies like Bitcoin, recording property deeds, or tracking goods in a supply chain, blockchain's purpose is to enable secure, transparent, and efficient transactions. What can a blockchain really do? Blockchain technology, while often associated with cryptocurrencies, has a wide range of applications that can benefit everyday people in many ways. Here's what blockchain can really do. 1. Secure transactions. Blockchain can facilitate secure peer-to-peer transactions, eliminating the need for intermediaries like banks. This could mean faster transactions with lower fees, which is beneficial for remittances or when you're sending money overseas. 2. Supply chain transparency. Blockchain can provide transparency in supply chains. For consumers, this means you can verify the authenticity of products, track their journey from source to store, and make ethical purchasing decisions. 3. Digital identity. Blockchain can provide a secure way to manage digital identities. This could simplify the process of verifying identities online, making it easier and safer to access services like online banking, e-commerce, or even government services. 4. Voting. Blockchain could be used to create secure, transparent voting systems, reducing the risk of fraud and making it easier for people to vote remotely, which could increase voter turnout. 5. Health records. Blockchain could be used to create secure, interoperable health records. This would give individuals more control over their health data and could improve the quality of care. 6. Copyright protection. For artists and creators, blockchain could provide a way to register and protect intellectual property rights and ensure they are fairly compensated for their work. 7. Decentralized finance, DeFi. Blockchain is the backbone of DeFi, which aims to recreate traditional financial systems, like loans or insurance, in a decentralized, transparent manner. This could provide financial services to people who are currently unbanked or underbanked. As you can see, the possibilities are endless. As blockchain continues to advance, the applications of this incredible technology will only become more diverse and powerful. How blockchain works. Step by step. Understanding how blockchain works can seem complex, but let's break it down into simple step-by-step terms. Step 1. Transaction initiation. A user initiates a transaction. This could be anything from sending cryptocurrencies like Bitcoin to another user, recording a contract, or even casting a vote in an election. Step 2. Transaction verification. Once a transaction is initiated, it needs to be verified. In a blockchain network, this verification is done by a network of computers, also known as nodes. These nodes confirm the details of the transaction, including the validity of the transaction details and the status of the participants. Step 3. Transaction added to a block. Once verified, the transaction is grouped with other verified transactions into a block. Each block has a certain capacity, and once that capacity is reached, a new block is created. Step 4. Block added to the chain. Before the block can be added to the chain, it needs to be given a unique identifier, known as a cryptographic hash. This hash is created from the transaction data in the block and is unique to that block. The block also contains the hash of the previous block in the chain, creating a link between the blocks. This is where the term blockchain comes from. Step 5. Consensus. The block is now added to the chain, but before it can be accepted, the nodes in the network need to reach a consensus that the block is valid. This is done through a process known as mining in some blockchains, like Bitcoin, where nodes solve complex mathematical problems. Other blockchains use different consensus mechanisms, like proof of stake. Step 6. Completion. Once consensus is reached, the block is added to the chain, and the transaction is complete. The blockchain has now been updated, and everyone in the network can see the new block and the transactions it contains. Can a blockchain be hacked? While blockchain technology is designed to be secure and tamper-resistant, it's not entirely immune to hacking. However, successfully hacking a blockchain is extremely difficult and requires significant resources. One potential vulnerability in blockchain is the 51% attack. This occurs when a single entity gains control of more than half of the network's mining power, allowing them to manipulate the recording and verification of new blocks. They could potentially double spend coins, spend the same digital currency more than once, or prevent other miners from validating new transactions. However, executing a 51% attack on a large, well-established blockchain like Bitcoin would require an enormous amount of computational power and is therefore highly unlikely. Another potential vulnerability is in the smart contracts that run on some blockchains. If there's a bug in the code of a smart contract, it could be exploited by hackers. This was the case in the infamous DAO hack on the Ethereum blockchain in 2016. It's also important to note that while the blockchain itself may be secure, applications and digital wallets that interact with the blockchain can be vulnerable to hacking. Many reported blockchain hacks are actually hacks of these peripheral systems, not the underlying blockchain. The different types of blockchains. Blockchain technology has evolved into several different types, each with its own characteristics and use cases. Here are the four main types of blockchains. 1. Public blockchains. These are open to anyone who wants to participate. They are decentralized and transparent, meaning any person can join the network, validate transactions, and create new blocks. Bitcoin and Ethereum are examples of public blockchains. The main advantage of public blockchains is their strong security and transparency, but they can be slower and require more computational power due to their consensus mechanisms. 2. Private blockchains. These are restricted to specific members by the network administrators. They are often used by businesses for internal purposes, as they offer more control over who can validate transactions and create new blocks. This control allows for faster transaction times and less computational power, but at the cost of some decentralization. An example of a private blockchain platform is Hyperledger Fabric. 3. Consortium blockchains. Also known as federated blockchains, these are controlled by a group of organizations rather than a single one. They strike a balance between the openness of public blockchains and the control of private blockchains. They are often used in the banking sector, where several banks may maintain a shared blockchain. 4. Hybrid blockchains. These combine elements of public and private blockchains. They allow for control over who can see and access the information on the blockchain, while still allowing for verification from a decentralized network. An example of a hybrid blockchain is Dragon Chain. Each type of blockchain has its own advantages and disadvantages, and the choice between them depends on the specific needs and goals of the users or organizations involved. The future of blockchains and their true potential. The future of blockchain appears both promising and provocative. The potential of this technology extends far beyond its current applications, and it's poised to disrupt traditional systems in ways we may not even fully comprehend yet. 1. Decentralized Internet. Imagine an internet free from the control of tech giants, where data privacy is a given, not a luxury. Blockchain could lay the foundation for a decentralized internet, or Web 3.0, where users control their own data and digital identities. This could fundamentally shift the power dynamics of the digital world, but it also raises questions about governance and regulation in a truly decentralized internet. 2. Token economy. As blockchain and cryptocurrencies continue to evolve, we could see the rise of a global token economy. In this economy, tokens representing real-world assets, like real estate, art, or even time, could be traded on blockchain platforms. This could democratize access to investment opportunities and create a more inclusive global economy. However, it could also disrupt traditional financial systems and require new regulatory frameworks. 3. AI and blockchain. The convergence of blockchain and artificial intelligence could lead to more transparent, efficient, and secure AI systems. Blockchain could provide a tamper-proof record of AI decisions, which could be crucial in fields like autonomous driving or healthcare. But it also raises ethical questions about the control and use of AI in a decentralized context. 4. Quantum threat. On the controversial side, the advent of quantum computing could pose a threat to blockchain. Quantum computers could potentially break the cryptographic algorithms that secure blockchains, leading to a quantum apocalypse. However, this also drives the development of quantum-resistant blockchains and cryptographic techniques. In conclusion, the future of blockchain is a thrilling journey into the unknown. It holds the promise of a more decentralized, transparent, and equitable world, but it also presents new challenges and controversies. As we navigate this uncharted territory, it's crucial to foster a dialogue about the ethical, legal, and societal implications of this revolutionary technology. If you have made it this far, comment down below with the word 100% to confirm that you have received the knowledge from this video. For more interesting topics, make sure you watch the recommended video that you see on the screen right now. Thanks for watching.